Hello everyone and welcome back to Garage Time. This week we're going to work on the front strut brace, which is also going to be homemade. But you're probably wondering, why are we using a laptop and all this test equipment to install a strut brace on a 45-year-old car? Well, welcome to Tom's Porsche Lab. Let's get going.
Garage Time.
Okay, a little while ago, I did a video on the seam welding, and I did some before and after testing. So seam welding was intended to increase the stiffness of the chassis, and I measured the chassis stiffness before and after and noticed a pretty sizable increase. If you're interested in that video, click right here. So to continue on that theme, and as I go through a lot of chassis modifications on my car, I want to know, does it make a difference or not? And some of you may have figured out by now, I'm a mechanical engineer and I love engineering, but sometimes it's kind of a curse. I like to know exactly what is happening and what benefit each part has that I put on my car. I have a feeling, at least on some modern cars, that these strut braces are somewhat gimmicky. So I think it's useful for myself and also for you guys to know, is this really a worthwhile upgrade? Okay, the function of the strut bar is to tie the two front strut towers together. Let me show you on my whiteboard what I'm talking about. Okay, sorry guys, my whiteboard was full of other gibberish, so I'm using this piece of paper and just drawing on the walls, so please forgive me for that. This is the suspension of the front of a Porsche 911. So here are the two tires, here are the front struts, and these are the suspension arms. So as your car comes down the road, and here I'm showing it kind of turning, making a left-hand turn coming down this page, there are forces on the tires. In this view, there's a force on the bottom of the tire where it contacts the road, and it wants to push the tire or fold the tire underneath the car. It's attached with the spindle onto the strut, and it's attached to the car at the top of the strut tower, that's right here, and it's also attached to the car at the suspension arm, which is shown in black right here. So this force that's trying to keep this tire upright is also creating a force on the top of the car in this direction. Now, because the way the car is constructed, and this is a passenger GT or a touring car, this structure of the front of the car is a big trough. That's so you can put luggage and other things in the car. So the thought with the strut brace is that if you attach both of these towers together with a bar, potentially a bar like on mine, it's going to come diagonal like this, well, the force that acts on the chassis is going to be strengthened by the other side. So if you're making this right-hand turn, this force is secured on just one side of the car, whereas the strut brace will put that force and distribute it across both sides of the car, thereby making the chassis stronger and also preventing this camber from changing as you go through a hard corner. Okay, all these cornering loads that happen on the four tires, or the two outermost tires predominantly, also gets transferred through the spindle. So there's a force that comes, through the tire, through the bearings, but a lot of that force is carried through here. And that also tends to push the strut. Now in this case, it pushes the strut inward. So these two forces are opposing each other, which is the genius of the McPherson strut design. That is the theory. And what I want to do is measure, how much force is inside this bar when the chassis is stressed and you're going through corners. So I've set up some instruments to determine, does this create a lot of force between these strut towers? And also, does the strut bar here actually improve the torsional rigidity of the chassis? Now, I have my doubts on that. Let me show you on the car. Okay, these are the brackets that I installed last week, and they are here to support the strut bar brace. And there's one on each side. There's a couple small tabs on the lower section on the driver's side That's to support a diagonal bar that goes from this lower corner to the top, and then of course the bar that goes from right to left. Now the connection of the strut bar to these brackets is through a pin or a bolt. So that's a pivoting type joint, and as the chassis twists, like I did in the previous seam welding video, I'll show you here in a minute, I'm going to twist the chassis, and the bar that comes across the top can also pivot in these holes. So the torsional stiffness is probably not going to be improved very much with just the top bar alone. Now the bar that goes across the diagonal could prevent that from pivoting, and so it might have an increase in torsional stiffness. We shall see. Okay, as I said earlier, I'm going to make my own strut bar across the top. But before I do, I'm going to make a temporary one that includes the instrumentation that I showed you earlier. So I'm just going to use, this is what I have laying around. This is some 1-inch square tubing, and it will serve as the same function as any of the aftermarket type strut bars. I probably will make mine out of aluminum. Okay, I'm drilling out these holes in the bar and on the bracket to fit these bolts. Now these are precision shoulder bolts, 8mm diameter. So it's important that the hole that goes through each of these parts is precision, because you can't have the bar sliding relative to the bracket. Nice, dead battery. I got this. Okay, this top bar is installed. It's good. I mean, it's temporary. Now I'm getting ready to do the diagonal, and I don't have any more of this material. Now this material is ideal because it fits right into the strut brackets because I made them 1 inch. But I do have this round bar. Okay, remember this is a temporary strut bar, but it's perfectly functional. I mean, there's nothing wrong with it. It's just, you know, a little bit heavy and a little bit crude. But I'm going to now cut it in the middle so I can put the sensor in to measure the loads in the bar. So if you remember last week, I had some concern about the smuggler's box cover. You know, how far is it going to open? So now we will find out. It opens almost all the way up, and the diagonal bar really isn't an issue at all. It's just about the smuggler's box cover. I had a comment from Joe and Robo who said just take the hinge pins out, make removable hinge pins on the smuggler's box cover if you really need to get it all the way open. Just pull the pins out and take it off, which is definitely a great idea. Thank you for that. Please keep the comments coming. I'm really digging it. That was a good one. Okay, now is where the instruments come into play, which is why I had the laptop and all this test equipment out on the bench. This right here is a load cell, and it uses strain gauges in the middle. I am going to cut the top bar and insert this directly in line with the bar. So this measures force. This one is about a 300-pound load cell. I happen to have this from some other engineering work, so I am utilizing it in this project just for the sake of learning and informing you guys about how these changes might affect your car. Now I only have one of these, So ideally I would have one on the top bar, one on the bottom bar, but because the top bar is the one that does most of the work in my opinion, we're going to only be instrumenting the top bar, and then I'll show you what my plans are for taking the bottom bar out of the equation, okay? Okay, I have some bolts inside this little tub here. They're soaking in muriatic acid right now. I'm stripping off the zinc plate so I can weld them on the end of this bar. These are the bolts that are going to attach that sensor to my strut bar so we can learn a little bit about these strut braces. Which reminds me also, while I'm waiting for that to work, please take a moment to subscribe to this channel. I do a lot of how-to videos, and like this one, it's a little bit about explaining why and how, and what modifications are really worth spending your money on. So thanks again. I hope to inspire you to work on your car and do similar projects. So don't forget to leave a comment, like the video, and subscribe. Okay, I just welded those bolts inside the 1-inch tube, and you know, this is temporary, so this should hold that sensor just fine. Okay, I have this load bar and load cell completely installed onto the strut bar, and all the bolts are tight, including these bolts right here where it attaches the sensor. So this is snug down onto here, so there's no slop in the threads, and then there's a jam nut on the back side of that one, so there's no slop in the threads. This is clamped as tight as I can get it with the bolt so that it hopefully has a little bit of friction there. Plus the shoulder bolts prevent any movement. Same is true on this side, and I also have the diagonal bar clamped in place too. Okay, I've also calibrated the sensor so that any of the offsets are minimized. So you can see it's reading just about 0 pounds. Okay, I'm just gonna set the computer to record. The computer will record the sensor output in real time. So instead of just giving you one number, it can give you a whole series of numbers. So if I shake the car, we should be able to see if there's any load in the bar over time. Okay, this is the section of data right here where I was shaking the car, and you know, this is just noise, random noise in the sensor, and then this is barely detectable where I was shaking the car. So the scale on this is about 20 pounds, plus minus 20 pounds. So it's not very much change in the bar. Okay, this diagonal bar is now disconnected, and it's just sitting here, no attachment to the car. So now all the loads in the car should be measured by this sensor and not this bar. Okay, with the bar disconnected, this is where I was shaking the car, and there's really not much change. This is like at the most a 10-pound signal. Okay, the sensor seems to be working. Here's where I was pulling, you know, right near the shock tower. I was just shaking the car at the shock tower. So same thing. This is about, see, 60 pounds between the top and the bottom. So it was alternating between tension and compression. Here's another quick test. I'm just going to jack up the right front and unequally kind of, you know, twist the chassis a little bit. See if there's any load picked up in the sensor. Okay, here's the results of me jacking the car up. So this is when it was on the ground. Here I am pumping it up with the jack, and then it dropped down. This is about you know, negative 20 pounds, and then I dropped it on the jack kind of on purpose. You see a little spike right there, and then here it is back on the ground. So the load in the bar is about, you know, between the highest and the lowest is about 20 pounds. That's really not a lot of force in the bar. Okay, I had a few tests planned, but the first one I think I'll try is the torsional rigidity test. And to do that, I need to use this bar. So this bar has these little, shoulder sleeves in it, so I can attach it right to the bottom of the suspension points. And if you remember from the seam welding video, I have this attached to the car, and then I put weight here on the end. Now, this round, I'm going to be a little bit more careful on how I put weight on the end. Last time I was just sitting on it for some kind of quick and dirty tests. Now this time, I think it's going to be much harder to recognize the influence of the strut brace. So I need to step up the game a little bit and improve the accuracy of this test slightly. So I'm going to be using some fixed weights on the end of the bar, and hopefully we'll be able to see a difference between with and without the strut bar brace. But I told you before I was skeptical of the strut bar brace, and I'm not giving up, but I do not expect a huge benefit here. So let's get to it. Okay, so the way this test works is this bar is attached to the bottom of the car, right at the suspension pan forward mounting locations, and it's attached on both sides, and then the driver's side is supported by a jack stand, and it's located directly underneath the suspension points. And then this side is not supported at all. This side is set up with a dial indicator, which measures the deflection of the chassis. So this setup purposely loads the chassis in a twist sort of environment. As I put weight on the end of the bar, it's going to deflect the passenger side down, and you can get the reading here. Now, the rear of the car is supported with jack stands, and so the jack stands are there at the rear, and the rear tires are off the ground. I can, using just my fingers, I can deflect the car. You can see the needle is moving, and I'm only using one finger. So this measurement is very sensitive to weight, and the chassis is pretty flexible when it comes to twisting. So I'm hoping the strut bar will improve it a little bit. Okay, I have my phone recording the actual measurement on the dial indicator. It's recording the deflection. I have the computer turned on, so it's actually recording a load in the bar. And then I have these 40-pound salt bags that I'm just going to stack on the end of the bar and watch the chassis deflect and do some before and after measurements. Now, right now, I'm going to do this test 3 times. Right now, it's the strut bar is in place, connected in 2 places, a 2-point strut bar. I'm going to connect it in 3 places using the diagonal bar, and then I'm going to disconnect it totally and compare all 3 of those tests. There's 1, 2. I'm using salt because I have a water softener in our house, and rather than buy bags of cement that I won't use, I can use this later on in our house. Okay, there's 160 pounds loaded on the car, and everything seems to be stabilized on the dial indicator. I'm going to shut off the computer and take a look at the results. Okay, here's the plot on my computer showing the force in the bar for the various bags. So here's 0 bags, 1 bag, 2 bags, 3 bags, 4 bags. And the difference between no bags and 4 bags is about 25 pounds of force in the bar. Okay, test number 2 involves attaching this 3rd attachment point on the strut bar. So I'm going to attach that right now. Test number 2 now with the 3-point attachment on the strut bar. This is the 3-point loading, and there's 1, 2, 3, 4 bags. The amplitude here looks to be just a tiny bit less. I mean, hard to tell with this fuzzy line here, but it seems to be a little bit less, and that's to be expected as the load is shared between the bar with the sensor and the diagonal bar. So I expect it to be a little bit less there, some load sharing. And then these numbers, I had to redo this one because I subtracted the dial indicator wrong. It's about 50 thousandths for each bag, 51, 53, 48, 53. This is with the 2-point. With the 3-point, it is less, 42, 45, 48, 45. So we are seeing a change in torsional rigidity. I'll do the math here shortly to see how much, but I'm going to do another test with the bar completely disengaged, and that will give us another data point. Okay, for the third torsional rigidity test, I have taken out the pin on the passenger side. So it's still attached on the driver's side, but this bar is just, you know, kind of flexible. You can kind of see it moving with my fingers. Okay, here are the results of the strut bar torsional rigidity test. And you can see there's 3 tests. They all fall within a line. Down here is the load that was applied in pounds. So this is in quantities of 50, but it was basically a 40-pound bag, then 80, 120, 160 as they added up. And then this is the deflection on this side in thousandths of an inch. So everything falls in a line, which means, you know, there's no permanent distortion, no funny behavior in the chassis. It's as expected on a line. For a given load, say here at like 150 pounds, or we didn't really go that high, let's call 100 pounds, the deflection was about 115 thousandths of an inch. That was with the 3-point torsion bar. Without the torsion bar, the deflection went up, which means the chassis is flexing more. It went up to about 100, I don't know, maybe 120 thousandths deflection. And then with the 2-point bar, it actually went up even more. So these 2 lines look like they're flipped. You would think that no bar would have more deflection than the 2-point bar. Or why is a 2-point strut bar worse than having no bar at all? And that's pretty confusing, although the only explanation I have on that is, and I'm not even sure this is a good one, the torsion bar might have actually locked in some deflection. So because the way it's attached to the car, it's clamped onto the strut brackets. And when I put the salt on the bar, the deflection sort of oscillated a little bit. And I have a feeling that the strut bar actually sort of held on to some of that deflection and clamped it in place. That could be why this line is higher than this line, but the fact is it's not a very big change. I'm only seeing as a percentage, I'm only seeing a small percent gain here. Not as much as I did with the seam welding. Okay, the change in deflection at the highest load was about a 9% change. So I do know that the stiffness might be even a little bit higher. If we look at the torsional rigidity, if I calculate that, it might be around 10% change. So the 3-point bar does improve torsional rigidity. It's not a huge factor. It seems like it's around 10%. Okay, for the next test, I would love to be able to take this rig and put it on the road and just drive around and get some real world measurements on the load on the strut bar and see kind of what the loads are. But as you know, this car is not drivable, so the best I can do is try to simulate the cornering that we talked about earlier on the diagram. So what I plan to do is kind of just drag the car along the ground and see if we can generate some forces on the tires that might generate some forces in the strut bar, just to see what happens. Okay, for this one, I think I've gone totally mad. I have this come along attached to the wife's car. The cable is attached here to the kind of the same spot where I attach this this bar or the tow hook there in the front. So I'm just gonna, you know, pull on this until it slips on the floor and see if it generates any force in the strut tower. Here are the results of the sliding test, and I can see a small dip here, but you know, that's like 5 pounds in the strut bar. It's really minimal. Okay, grabbing the tire at the top and shaking it did provide the highest forces so far. So you can see this is where I was shaking, and I took a little break and I shook it again. These are pretty consistent. This is about, you know, at the highest point, plus 20 pounds, and then the lowest point, minus 20 pounds. So you're seeing a plus minus 20-pound swing in the sensor, which is still pretty light duty. Okay, thanks for sticking with me this long. My last test is kind of a drop test. I have the car supported up in the air here on the front, and this little wooden peg is the only thing holding the car up at the moment. And I have this block of wood underneath the right front tire, so I'm gonna drop the car by hammering this piece of wood out. The rear tires are chock, so it's not gonna roll anywhere. It's just gonna come down hard on the right front, and that's gonna put pressure in the damper inside the strut. So that's gonna load up the strut tower just a little bit. Remember, the car is supported by the torsion bar, not the strut. Okay, I should probably say, don't try this at home. It's gonna drop. There's about an inch gap between the tire and the block, so it's gonna settle down and compress the suspension right away. So here we go. That was fun. Okay, this time it's a little bit more significant. This is before the drop. Here's the drop, and then it settled back down when it was resting on the block. So the scale is a little different now. Each division is 20. So this is about 20, 40, 60, almost about, I'd say 70 pounds in the bar, and then it quickly died off. So that's the highest I could get, 70 pounds in the bar, and that was a pretty dramatic drop. I mean, you saw the car sort of settling down after it was dropped. All right, car fans, so what does all this really mean? All this mumbo jumbo forces, yada yada. I think there is a lesson here, even though the testing is not done. I mean, I really need to repeat this test with the car in driving conditions, and I'd love to do that. Believe me, I wish my car could drive. But the numbers are, pretty low in terms of just the strut bar. Now, the diagonal bar seems to be more effective than the strut bar because the torsional rigidity, that 10% increase, was due to the diagonal bar, not due to the strut bar. So if you are going to buy a strut brace, I recommend the 3.1. The forces, I got maybe up to 70 pounds. I don't know if I could generate more force actually driving the car with a fully weighted front section, with a fuel tank and whatever else is missing in the front. I don't know in actual driving conditions if I could stress the chassis even more. I put a lot of torque on that with that bar sticking way out the end, and it didn't translate into a lot of force in the bar. I also wanted to refer to some other work done by another Pelican member. He applied a force directly to the shock tower to measure how much it deflected and what that deflection related to in the camber change. So he was able to put like 200 or 300 pounds on the tower directly and notice that it really had a small change in camber gain. So his conclusion was that the strut bar isn't that effective, and I tend to agree with him. I don't think a 70-pound force going around a corner is really going to make a big difference. Not to say that it's not useful. I think in order for it to be useful, the car has to be driven extremely hard. You saw me just drop the car, and that would probably simulate a hitting a cornering curb or something, and that did stress the chassis pretty high. Put a spike in there, and the torsion or the strut bar was able to slow some of that down, or at least brace some of that by taking the load and putting it onto the other side. So I think it's useful. I would recommend spending money on other things first. I think tires would be a much better investment for improving handling. If you still have money left over, shocks. If you still have money left over, look at the suspension bushings, because at 70 pounds, you're not changing the camber angle very much. The actual strut tower that Porsche designed is pretty strong, and the other fellow at Pelican Parts also said that the movement of the strut towers is pretty small, at least for a torsion bar car. If it's a coilover car, you're putting a lot more pressure in the strut towers. And I may do coilovers in the front. I'm undecided on that. That's why I'm putting provisions in now, so I could do that later. But as the car is with torsion bars, I don't see a huge benefit. If you were to change the bushings and remove some of the flex in the bushings, I think that's going to be a better upgrade than the strut tower brace. So, you know, why do we see so many strut tower braces in cars? Even sort of other makes of cars like the Hondas, the Fords, everyone sells strut tower braces. And unfortunately, I think it's a little bit of a gimmicky tactic. You know, it's something that people can bolt on, and they usually come in cool colors and stuff, and it's something that's visible. So it's a little bit of the monkey see, monkey do approach. I wanted to start this testing by trying to put some numbers on that. And I think that you can make your own decisions. The results that I'm seeing is that this is not a very significant upgrade. I would love to hear from you if you have other experience. So if you are someone who drives your car very hard and you can feel a tangible difference between the strut bar, you know, there or not, I would like to hear how you think the car drives different. I may be wrong. I might be missing something. If you see something I missed, please let me know in the comments below. This is all for the Porsche community. It's not just for myself. I'd love to learn more about this. If you have some experience, or if you've decreased your lap time, or something good happened with just a strut brace by itself, would love to hear that. So that's my synopsis. Thanks for sticking around on all these tests I did. It was about a day's worth of work, so I don't think it was a total waste of my time, but I need to get to sanding. You didn't think I was going to let another week go by without sanding, did you? Come on. I got from here to here.